the difference between a non-proportional, which is this one, and a proportional, which is this one. Proportional is because it goes through the origin. Non-proportional does not go through the origin. What do the graphs for fitness, connection, and fit for life have in common? Well, they both have number of visits, and they both have total cost. Number of visits is the x-axis, and total cost is the y-axis. You need to make sure you know what your y-axis units are and what your x-axis units are. Okay, what do the graphs have in common? That is what they have in common. What is different about the two graphs? Well, one is non-proportional and one is proportional. Plot the x values, the x and y values from each graph. Well, let's plot 0 visits. Well, here's my 0, and I go up, and it's 20. 0 visits for Fit for Life is right here. It doesn't go anywhere. It's still at 0. 1 visit for Fit for Life is right here. And I go up, and it's at the 10. So my total cost is 10. Process. Process is the equation. What type of equation can we use to solve 0 visits to 20? Well, our equation is y equals mx plus b for non-proportional. If it is proportional, your b is your y-intercept, which means if it's proportional, it goes to the origin. Your y-intercept would be 0. So, if I put my process as y equals mx plus b for both, no, I cannot just leave it there. I have to plug in my m, which is my slope, and my b, which is my y-intercept. Okay, that's pretty easy. Well, my y-intercept, 20. Okay, I'll come over here, erase my plus b. What was my y-intercept? Well, it was a positive 20, so I will put a plus 20. Okay, over here, my y-intercept, well, it intercepts right there at the 0. So I will come down here, and I will erase my plus b, and I will put my plus 0. Okay, now I got to plug in my m. Well, what is m? M equals slope, which equals rise over run. Okay, well, let me plot 2 points. There's one, there's one. I draw my right angle. Well, what is my rise? My rise is from there to there. Well, this starts at 50 and goes to 40. So what's 50 minus 40? 10. So 10 is my rise. Let me write that down. What is my run? Well, my run is from here to here, 2 to 3. So my run is 1. 10 divided by 1 is 10. So my slope is 10. So then you would come down and you would erase your m and you would put your slope, 10x. So if I wanted to see if that worked, what is y equals for 1 visit? 1 visit would be y equals 10. Well, this is x because my visits is on my x-axis and my total cost is on my y-axis. So 10, let me plug in my 1 plus 20. Well, 10 times 1 is 10 plus 20 is 30. Okay, let me put 30. Total cost for 1 visit, let's go check the graph. 1 is all the way up. Yep, it's 30. So that is my process. You need to plug it in all the way down. Okay, fit for life process. I still need to put my m in. Okay, so let me go plot my points. Well, I want to put a point here and a point here because they intersect the lines that go this way. Okay, when they intersect, you can plot a point. So I'm going to plot my point here. I'm going to plot my point here. I'm going to draw my right angle. I'm now going to see what my rise is. Well, my rise starts at 40, ends at 30. What's 40 minus 30? That would be 10. So my rise is going to be 10. What is my run? Well, my run is horizontally. It is from 3 to 4. So what's 3 minus 4? 3 minus 4 is 1. So my run is 1. 10 divided by 1 is 10. So my slope is 10. So I would come down here and I would replace, or what we call plug in, for m, what my slope is, 10. Well, this is a 0, excuse the bell, this is a 0 y-intercept, so in reality, I don't even need that because the 0 crosses out. So let's plug it in. Our x, remember this is our x and this is our y because our number of visits is our x-axis. So what is 10 times 1? Well, that's 10. That is our process. You need to plug